here. And Timothy Guo from BLUEsat is talking about student activities in BLUEsats and the CubeSat relevance activities. So BLUEsat, for those who don't know about them, BLUEsat is a student organization in UNSW, and they work very closely with AXA, and BLUEsat has strongly supported us in our ground station operation for the AXA UNSW EC0 CubeSat. So there we go. Take it away.
Okay. Thank you, June. So, like I said, we're at BLUEsat. We're a student-run engineering group. My name is Koschnick. I am the lead of the GreenSat project. This is Timothy Guo. Yep. He's lead for the ground station. Okay. So, BLUEsat is a student-run society focused on space engineering development. Our aim is to take on practical space engineering projects, and in doing so, give students hands-on experience in space technology. At the moment, our projects include the ground station and a collaboration with the QB50 project, the GreenSat project, which I'll be talking about later, our satellite subsystems, and basically designing and building those, stratospheric balloons. Elias talked about that yesterday, and our off-world robotics team.
Alright, so I'm the lead for the ground station team at BLUEsat. So a quick overview of our primary two aims at ground station is to provide communication link for orbital systems, satellites, and for balloons. And our second aim is to connect students at UNSW, provide them with experience, provide them with hands-on theory, practical skills, and introduce them into the space industry. We use two Yagi antennas, the 70 centimeter Yagi antennas. They operate on the amateur wavelengths. In terms of software, we use GNU Radio, gPredict. This is to establish coordination and also track satellites. For TNC, we use hardware and DieWolf. DieWolf is a virtual TNC. This is for packaging, decryption, and encryption. And before we let any old recruit to BLUEsat start operating on ground station, we put them through vigorous theoretical and practical training to be able to handle the BLUEsat ground station on their own. This is through a partnership with Waverley Amateur Radio Club and the St. George Amateur Radio Club. They actually are really great help, but so far the only resources that we have in terms of professional advice is mainly great help through AXA. They provide us with a lot of help on our ground station and BLUEsat in general. And then also through the two amateur radio clubs, they provide training for the amateur radio license, which we put through each new recruit. They go through theoretical, they go through regulations, they go through practical assessments, and by the end of it, they're able to pretty much handle the ground station independently if need so. But obviously, we always have someone who's experienced on site to make sure they're doing everything accordingly. So, as we all know, there was a very successful launch of the EC0 QB50 by AXA. It will be deployed in a while, not for a couple of months. But in the meantime, we're pretty much just making sure everything's working with the engineering model, working very closely with June, making sure everything's going according to plan. We hope that this will be a really good pathway for future missions projects to work with partners. Because we have this ground station, we would love for corporations, people in the industry to work with us, utilize these resources that we have, this team that we're all so eager to learn about and get introduced into the space industry. Currently we have two, which is the Omonotanashi, that's Japan's own CubeSat, which plans to land on the moon. This is due in 2018, so it's still not for a while. And the second one that we're also planning on is BLUEsat's GreenSat, which Ben will be presenting about.
So GreenSat is our major project for 2017. And basically what we're aiming to do is to provide a platform for biological and agricultural experiments in space on a CubeSat. This will provide a cost-effective means for performing these experiments. I think our I think our most similar competitor is 250 kilograms. So it's a big step down, and obviously a big step down in cost as well. Our focus is on paving the way for agriculture in orbit to feed astronauts in the future, particularly with the more prolonged space missions that are going on and our eventual going to Mars and stuff. When you get this technology down pat. We'll be trying to recreate conditions we would expect on these vessels, but obviously within the restrictions that we are at CubeSat, we're very small. We need to design with the following in mind, so we don't kill our full specimen. The atmosphere, we need to maintain the pressure and the temperature inside. The radiation, this is proving to be a bit of a tricky one, and we're still working on this. We're still in the early research phases at this point. Basically, we need to protect the specimen from the radiation levels to a reasonable degree. The chemicals and nutrients inside the sphere, so obviously we need to have all the nutrients in the soil or agar or whatever we grow it in. We need to make sure there's enough carbon dioxide or oxygen, depending on the specimen we use, so that it can complete its life. We need to illuminate the organisms, assuming that there's photosynthesis going on. We can either do this through natural sunlight, which obviously we don't need to power that, but then we've got problems with radiation and controlling the illumination. Or we could use artificial light, which would be a huge drain on our very limited resources and power. So we're still tossing up between those two ideas. Artificial gravity through centrifugal forces. So we're hoping to use a bit of a tethering system to separate the CubeSat out and rotate it to create centrifugal forces. We're still working on that mechanism. That's still very undefined, but we're aiming to get that done. Population levels. So if we have a more complex biosphere that maintains the chemical levels on its own, then we need to worry about the population levels and make sure they're maintained at a stable level. And contamination of the space environments. Obviously, we're sending a biological payload up there. If something goes wrong and the habitat ruptures, we need to make sure that we're not creating a new biohazard in orbit. So that's what we have to consider. Now, the project is still in its early research phases, so we don't have all the details just yet, but pending successful application, we're hoping to present this at the International Astronautics Congress in September. And next year, we'll be moving on to a more detailed design. We've got out all the details, get them all right, and start working on our ground experiments.
So just wrapping up about BLUEsat, we bunch all these UNSW students gathered here together. All of us have a massive interest in the space industry moving forward. This doesn't just include engineers, this is also commerce students, we have operations team. We all have this aim to move forward, go somewhere towards in the space industry. And we have these resources that you guys can actually talk to us, come talk to us about, connect with, we're going to connect with, and also you can drop in your name as well, because we're all students, we're going to be moving forward into somewhere in the space industry. If you sort of put your name in, we'll sort of hear about it. Perhaps later on work for you guys, who knows. But yeah. Right now we're looking for collaborations with existing missions, make use of our resources. We also want to launch our own CubeSat. We would like to do this through outside commission or perhaps through a BLUEsat design mission. And last of all, we would love to get professional advice, sort of guidance along how we're doing, where to go from there, support, and last of all, monetary assistance. This is sort of a big one. Everything doesn't really work if you're just like running off just your own garage or something. So monetary assistance, that's also a very big thing. And last of all, so probably take like a quick picture. There's like contact info. We won't take any questions now because everything's sort of pushed for time. We will be here if afternoon tea is still there, or the morning tea, it's still going to exist. We can talk to us. We'll probably set up something for that. So thank you for listening.
Thanks, Tim and Ben. I'm sure there'll be more questions for you during morning tea.